Hello everyone, today we are solving the problem consecutive XOR starter 73 division 1. So we have given an array A of length n. We can perform the following operation on A. We can select the index I between 1 to n minus 1. Okay, it means we can't select the index n, which is the last element index. Okay, and we can select an integer x between this range, which is less than 2 to the power 20. Okay, but greater than equal to 1, and we can set the AI with the AI XOR X and AI plus 1 element with the AI plus 1 XOR X. Okay, we are performing the we have taken the index I, so we are just changing the AI element and AI plus 1 element. Okay, and we have to determine whether we can make all the elements of A equal or not. If we can, then we have to print yes, otherwise no. Okay, so let's see some observation how we are performing the operation on the elements of array. So I have taken the four elements and I have written the ith bit of each element. So it is 0011. So if I apply the operation on this index, then uh, if the x element have the ith bit is set, then the this element the ith bit will be set because I am applying the operation on this index. Then I have to take the XOR with this element and this element, I and I plus 1 element. So if x element has set the ith bit, then this bit will be set, so it will convert into like this. Okay, so as you can see, all the elements have ith bit is set, so it is same now. Okay, let's see another ith bit. So here you can see there is two set bit and there is two unset bit. So I can apply the operation on this bit. So if the x element have the set ith bit, then this will be 0 and this element will be 1, because both of the consecutive elements the operation will be applied and the ith bit will be changed. So actually it will be toggled. If there is 1, then it will be 0. If there is 0, then it will be 1. So after this operation, I can apply the operation on this index. So XOR will be taken will of this element and this element. So both are 1, so both will become 0. Okay. So now the ith bit have all the zeros, so element is same for this ith bit. Let's check the another ith bit. If the ith bit is like this, which contain three ones and one zero, basically three set bits. So if I apply the operation here, then one will be toggled or changed to zero, and adjacent element which is this, it will be one. So after this, I can apply the operation here. So it will be 0 and it will be 0 now, but I can't choose this index because it will become 1 and it will become 0. There will remain one element whose ith bit is set, so I can't change all the elements either to we can't change all the elements whose ith bit is all the ith bits are 0 or all the ith bit are 1. So I can't make the element same. So simply meaning is, if there is even number of the ith bit in the is even, then you can unset all of them. If number of ith bit is odd, then you can't. So as I have written that number of ith bit is even, then you can unset all of them. Yep, and we have did. And number of ith bit is odd, then you can't make same. Okay. So I have taken the four elements still. Let's see what about if we have elements 5, which is odd. So if in this example we have 5 elements and I have written the ith bit of each element. Now you can see this example. We have 5 elements. So for each ith bit, either we have the number of set bit is even or number of unset bit is even. Basically, in this ith bit there is 3 odd, so I can't unset all of them. But you can see that there is 2 unset bit which is even. Basically 2 unset bit, so I can set them. Yep. So I can apply the operation here. It both of them will be set, and all of the elements have ith bit set. So all of the elements are same for this ith bit. Let's see the another ith bit. Here you can see there is even number of 1. So and I have already applied the operation in the above example. You already know that I can unset all of them like this. Okay, let me apply again. Like, you will wonder how can I unset them, because I can apply the operation here. This will be toggled to 0 and this will be toggled to 1. So for each operation the bit 1 is shifting. So I can apply the operation here, then this will be toggled, then I can apply the operation on this index, then it will be 0, and this bit will be 1. Now I can apply the operation here, then all of the bits will become 0. So here you can see that for the if n is odd, then answer is always yes, because if in each ith bit either there is even number of set bit or even number of unset bit. If there is even number of set bit, like even number of set bit, I give you example like this, then you can unset them. You can apply the operation, then all the bits will be unset. But if there is even number of unset bit, like in this case, then you can apply the operation and all of the bit will become 1. Like you can apply the operation here, the all of the bits will become 1, and in this case you can apply the operation here, then all of the bits will become 1. So for n, if it is odd, the answer is always yes. Okay, let's see some examples. So there are 4 elements A, B, C, D, which is 15, 12, 18, sorry, 10 and 8. And I have written the ith bit of each element, the third bit. So there are 4 ones. So for the third bit, there are 4 ones. So you can either unset all of them or you can remain set all of them. Okay, now see the second bit, there is 2 1. So there you have two choices. You can either set these two zeros by applying the operation, or you can unset this 2 bit by applying the operation. Okay. Now if for the first bit there is again 2 set bit and 2 unset bit, same concept. Now for the zeroth bit there is only one set bit, one set bit. So you can't make the all bit either set or unset. So in this case the answer is no. Okay, let's see this case. The total number of elements is 5. You already know the answer is yes. Why yes? Let's see the third bit. There is 2 set bit. You can unset them. All of the bit will become 0. For the second bit there is 4 bit set. You can apply the operation. All of the bit will become 0. For the first bit there is even number of unset bit. You can apply the operation and you can set the unset bit. So all of the bit will become 1. And for this case there is no unset bit which is even. So you don't have to apply operation because all of the bit is set. So in this case the answer is always yes. So let's see some problem test case. So the first test case is 3223. So again I have written the index of bit of each element. 011 which is 3, 010 which is 2, 010 which is 2, 011 which is 3. So for the second bit there is no set bit, all of the bit are unset. Okay, in this case all of the bit are set, there is 4 element, so this case is also nice. In this case for the zeroth bit there is 2 set bit, so you can make unset, or there is two unset bit, you can apply the operation and make them set. So this is also nice. So answer is yes. Let's see another one. So let's see this one case. So the second bit, there is two set bit, you can unset them. For the first bit, there is two unset bit, again you can unset them. For the zeroth bit, there is three set bit and three unset bit. So you can't set either set all of them and you can't unset all of them. So answer is, that's why no. So let's see some code. Okay, so initially I have taken the input of n, then input of array. So if the n value is odd, then answer is always yes, because when n is odd, then for each ith bit, either there is even number of set bit which you can unset, and either or even number of unset bit you can make set. So all of the bit, for each ith bit, you can make set all of the bit or you can unset all of the bit. So then I just run a loop from 20 till 0. See the constants. You will get to know why I run loop from 20, because there will be the at max 20 bits. Okay. So after that I just declare a variable 0, which is just to count how many bits are set for each element in the array. If the element bit is set, then I just incremented the O, and I am just checking whether O is odd or not. If it is odd, then I can't set or unset all of the bits. The answer is no. Otherwise, the answer is yes. So if you find this video helpful, then you can like and subscribe to our channel. Thank you.